In electricity calculations, this is our second part. And so Ohm's law we've just dealt with at the bottom of this page. And now we're going back to what we saw in the first chapter, first section of this course. And this was linking power, energy, and time. Power we know is in watts or kilowatts, energy is in joules or kilowatt hours, and time will be in seconds or hours. Now, with all these formulas, you don't have to memorize them. You will be given a formula sheet to use. So this reminds you how to find energy, how to find power, how to find time. And if you can't remember that, go back to those earlier videos that showed you. All right, power part 2. Now we're going to link power and current and voltage together. So we know power is in watts, and it's the rate at which energy is used or produced. How many joules of energy made per second, or how many joules of energy used per second. Current is measured in amperes, coulombs per second is the flow rate, and voltage is the joules per coulomb. It's the oomph that electrons have. So amperes times volts. Well, amperes are coulombs per second, volts are joules per coulomb. The coulombs divide out, and we end up with joules per second. I know the J's don't look that good. And joules per second happens to be watts. So from this, we get power equals current times voltage. And that means we get 3 formulas. So, reading question, if we're after power, we're going to have current times voltage. If we're after current, we're going to have power divided by voltage. And if we want to find voltage, then it's power divided by current. Now in this game, one of the things we've got to watch out for is sometimes you have to figure out are you using the PET formula or the PIV. If you see energy and time, then you're using PET formula. If you see current and voltage, then you're using the PIV formula. It also reminds us that these kind of questions are often about overloading circuits. And so we'd look at this one to find out if our current is going to exceed the circuit breaker rating. So we have Bubba using a table saw. We have a current, we have a voltage, and we need the power. So we go power equals current times voltage. We plug in the numbers, and you probably don't need a calculator to figure that out. And it's 420 watts. Formula, substituted numbers, answer. If you follow these steps, it's really painless. Now, Josephine uses a 1,000 watt kettle. Will it trip a 10 amp circuit breaker? And we have to make some assumptions here. The question, strangely enough, is going to be asking you to find the current. And when the voltage isn't supplied, assume it's 120 volts. So we're going to be going and figuring out current, I equals P divided by V. Here's our P of 1,000 watts. We're going to divide it by 120 volts. When we do, we get 8.3 amps. So write in formula, numbers, there's our answer, but we haven't fully answered the question. Now we look at the 8.3 amps we calculated. It is smaller than 10 amps, so it will not trip the circuit breaker. And that's what you do there, and that's a very typical question. I love to ask circuit breaker questions, which means you're going to be finding the current. Now we have Bubba Louie with a 400 watt waffle iron, 1200 watt toaster, and 300 watt TV, all in the same 120 volt circuit. Well, our total power, we're just going to add those up to get our 1900 watts, and we have our voltage of 120 volts. Will it trip a 15 amp circuit breaker? Well, we're going to be using the same formula, just different numbers. Okay, I'll get that out of the way. So our total power we said was 90 watts, P, and that's a subscript big T for total. Gives us our 1900 watts. Now, we plug in our numbers. 1900 divided by 120 is 15.8. 15.8 is bigger than the 15 amp circuit breaker. So yes, that should trip the circuit breaker. So that's a good place to stop. So now we've done Ohm's law. We briefly talked about the PET formula. And now we've done PIV.